How you doing, guys? Hello, guys. Another straightforward problem. I'm bringing as many problems as I want, as I can, so you can practice and practice and practice. But you don't have to solve every single one of them. But it doesn't make any good that you just watch me solving the problems. I always say that you don't watch the professor solving the problems. You try the problems on your own. And if you get stuck, then you watch the solution. And then you try on your own again. This is a gusset plate. We already discussed what a gusset plate was and what form was used in a different video. And then we have the three bars here connected for a truss to that gusset plate, and this is a joint. This is a typical configuration of a joint in a truss. So the problem is asking only the magnitude and the direction of the resultant force acting on the plate. What are we going to do? Same situation, same similar approach. First, find components. Find resultant in X, resultant in Y. 3, even easier this one. Find resultant force as a square root of X squared plus Y squared, and find direction. In any way, usually, I'm just putting this here as a reminder for you, inverse tangent, not necessarily, but this is the way you're used to do it. So let's do it. For the X component, we have three different values, three different forces. By the way, we need two unknowns, right? We have two unknowns, R and theta. And we have two equations, forces in X and forces in Y. So that's what we are doing. Then let's find the three forces in X. First, this one. You have that little triangle, remember? But by now, you shouldn't even be thinking about calculating that angle. So it's going to be 4/5 multiplied by 650. 4/5 multiplied by 650. That's the value for that horizontal force. For F1, everything goes in the X direction, so 900. And for F2, which is this one, the horizontal component is just 750 cosine because it's adjacent 45 degrees. So find resultant in X. All of them go to the right. So it's going to be 4/5 of 650 plus 900 plus 750 cosine of 45 degrees. Let's do that. 4/5 of 650 plus 900 plus 750 cosine 45, 1950.33 Newton. And remember, it's positive. That means that it's going to be acting to the right. Now we do the summation in the y direction. Okay, what do we have in the y direction? We have this component, this one, and it's 3 over 5. 3 over 5 multiplied by 650. Now we have this component of this one, or this one, which is the same, and that will be 750. Now it's opposite to the 45, so it's going to be sine 45, and this one doesn't have any component in that direction. So basically what do we have here is 3 over 5 times 650, but it's negative, you see, pointing downward, negative. And then you have this positive, 750 sine 45, for a total of 3 over 5 times 650 plus 750 sine 45, that's 140.33. And because it's positive, the result, that means that it's acting in this way. Now the problem asks what? Magnitude and direction. Okay, magnitude and direction. What I do, I still, I like to do my gusset plate, whatever, put my value here, I put my axis, X and Y, and then I know that I'm going to go to the right, 1950.33, and I'm gonna go up 140.33, and this is my resultant force. And this is gonna be the angle that I'm calculating. What is the resultant force? Square root of the summation of the squares. Resultant force, 140 whatever square plus 1950.33 square, square root, elevated 2.5, 1955.37 Newton. And now the angle. If I want to calculate this angle, I can do inverse tangent of this divided by this, and that will be an angle of, let's see, inverse tangent of 140.33 divided by 1950.33. Go ahead, 4.12 degrees. What is the result? Okay, what are the results? The result is the resultant force of all the forces acting on this plate will have a value of 1955.37 Newton at an angle of 4.12 measured counterclockwise from the positive x-axis. Mission accomplished.